Welcome back. Okay, I'm very excited to be here again to revise with you the chapter on waves, but I'm only touching on one specific subtopic, that is on interference of light waves. Again, interference of light will be the topic for this morning. Now, once again, I would like to encourage you to know that even as you look at interference of light, it might look difficult, but actually it is very simple. But you must get back to the basics. Just recall what you have learned, and I will guide you along so that you will know what to do when we come to the interference of light. Now, at the end of this lesson, you would understand better what interference of light is, and you would also be able to solve calculation problems involving interference of light. Another reminder, to study this well, it is more than just reading. After you have read just once, remember the key is to answer many questions and write down, draw, sketch, and then you will do well, because that is the meaning of rehearsing to understand concepts. Let us take a look at the question. Here I have chosen a simple question on interference of light. Let us read it together. The diagram below shows the interference fringes by a monochromatic light source in a Young's double-slit experiment. So what you see is actually the fringe patterns that you get when you did the experiment in the lab. So let's say these are the experimental results of an experiment that a student has done in the lab. The distance between the two slits is 0.6 millimeters, and the distance between the slits and the screen is 2.0 meters. The question is, what is the wavelength of the light that is being used? So, once again, let us take a look. Remember, in one of my lessons, I mentioned that you must familiarize yourself with the formula page and use this page to understand concepts. So, over here, you can see that there is one formula that we will use. I'm sure you will know which one. All right, let's take a look at this one. Lambda equals to AX per D. So this is the formula that we are going to use. All right, are you ready to work out the problem? All right, let's go to the problem now. Now, in this question, we are using lambda equals to AX per D. So we need to write down first and foremost every one of the quantities. Namely, what is A, what is lambda, what is X, what is D. Okay, step by step, we'll do it together. Now look at this question here. We are given that the distance between the two slits is 0.6 millimeters. So what is this? This is A. That is the symbol that we must be familiarized with. What else is given in the question? Look at this. 2 meters. What is it? Distance between the slits, the double slit, and the screen. And if you recall and you revise your work well, you know that this is actually capital D in the equation. So D is 2.0 millimeters. Remember, I mentioned in one of my lessons, in fact, in every lesson, units, very important. All right, take note of units. A is in millimeters. D is in meters. What happened? What did I do? I wrote down millimeters. All right, so that is a mistake. You have to be very careful. Look at the units. Now, the next section now is very, very important. Lambda equals to AX per D. That is the equation that we are using. In fact, we want to calculate lambda. And I need to know what X is, because I have written down what A is and what D is. Now, X is actually the distance between two successive bright fringes or two successive dark fringes. So in this case, let us say that the red fringes are the bright fringes and the white one, let's call it the dark fringes. So which means that x is this. We will have to write it down very, very carefully. Alright, what is x? Now look carefully here. I'm writing it down here. I am taking the midpoint. Alright, so this is considered the midpoint. Okay, so let me amplify it for you. This is x. In other words, x is either from here to here, this is x. Alright, so this distance is x. Alright, so this distance is x. Or, if you do not want to use that, you can also take the other distance, which is from the center to the center of the dark fringe. Let's consider it as the dark fringe. So, this is also x. Alright? So, when I use the diagram now, you will notice that 1, 2, 3, 4. So altogether, how many x's are there? It is actually 4x. Okay? 1, 2, 3, 4. 4x is given as 6.7 millimeters. Alright? So now I will write down 4x equals to 6.7 millimeters. Okay. Now, what is x? X is 6.7 millimeters divided by 4. So, if you look at this equation now, I have already obtained A, X, and D. I need to calculate what lambda is. It's quite straightforward, isn't it? Alright, let us put it all together now. Let's put it all together and answer the question now. Alright, so I have lambda. Let me write it down again. Lambda equals to A x per D. Okay, and what is A up there? Just now we have already written that A is 0.6 mm. 0.6 mm. Alright, I multiplied by x. I use a bracket. Okay, 0.6 multiplied by x. X is, look at here, what did I get? 6.7 mm divided by 4. Alright, 6.7 mm divided by 4. 6.7 mm divided by 4. Okay, and what do I have? Divided by D. Divided by D, D is 2.0 meters. Alright, so far so good? Hey, wait a minute. I have intentionally written down this way to see whether you are careful with your units or not. I must not write down mm, and then I have the meter down there. All the units must be the same. So either I change everything to millimeters or I change all the units to meters. But normally for wavelength, the answer is given as in meters. So we change everything to meters. Alright, so what do I get? The first step, 0.6 I must multiply it by 10 to the power of negative 3. And this is in meters. Next, I have 6.7 divided by 4. I must multiply it by 10 to the power of negative 3. Again, this is in meters. And at the bottom, I have the denominator. I have 2.0 meters. Okay, let me highlight it for you. I have got meters, meters, meters. Now, this is one of the most important things that you must pay attention to. Many a student knows the concept, but the mathematics, they got it wrong. They mix up the units and their answer is wrong. So, just remember when you have the correct units, meters, meters up there, and in the denominator you also have meters, then you would get a good calculation, you will get a correct answer. So after this, you work it out, get your calculator, be very careful, punch it 3 times, double check, triple check, and then you should be able to get your answer as 5.025 multiplied by 10 to the power of negative 7 meters. Now remember, this is not the theoretical answer, but this is an answer obtained by a student in the laboratory doing an experiment on interference of light. Alright, is it clear now? So this is something simple. Go back, look at other questions, try out and answer many times, and I am sure you will do very well. So once again, I'm sure you have understood better the interference of light, what it means, and then you can solve problems involving calculations for interference of light. So with this, I would like to say once again, thank you very much, and it is my prayer that you will do well in your physics, you will improve, and may God bless you. See you again the next time round.